over 1 up 1, over 2 up 4, over 3 up 9. Very good. Using a complete sentence, explain what parameter changes describe the equation 9x squared minus 14 when compared to the parent function y equals x squared. Okay, well, I already showed you how to do this on the calculator. So using complete sentences, okay? The coefficient in front of the x squared is a number greater than, well, technically it's a number whose absolute value is greater than 1. But since we haven't talked about absolute value the entire year, I'm just not even going to mention it. But absolute value is a measurement. It's just a measurement that it's a measurement of a distance, the distance between a number and 1. So essentially, the absolute value is always a positive number. So even if this were a negative 9x, a negative 9, the distance that negative 9 is from 0 is still 9. So ignore everything that I just said. The coefficient in front of the x squared is a number greater than 1, a number whose absolute value is greater than 1. Thus, the parabola will be narrow. Oops, parabola will be narrow. Good thing I'm narrating, huh? You can't read this writing. The coefficient is positive. The coefficient 9 is positive. Thus it will open upward. Thus it will open upward. So we've talked about the 9, we've talked about the positive in front of the 9. Now let's talk about this negative 14, period. The negative 14 will shift the parabola, you could even say the vertex of the parabola down 14 units on the y, or the vertical axis. All right. The coefficient in front of the x squared is a number greater than 1, is a number whose absolute value is greater than 1. Thus, the parabola will be narrow. The coefficient 9 is positive. Thus, it will open upward, concave up. The negative 14 will shift the vertex of the parabola down 14 units on the y-axis. If you need to see this, you can just graph it on your calculator. Okay, let's move along here to number 9. Okay, let's see here. Okay, graph y equals 4x squared and y equals 1/3 x squared to the graph on the right. So let's clear those out. We have 4x squared and 1/3 x squared. 1/3 x squared. Very good. So there are two functions. I'll make the 1/3 one darker. Okay, so we can see it on our graph. So let's see what they look like. Yep, there's 4x squared. Whoa, and there's 1/3 x squared. Which equation has the wider graph? Well, we can always tell which equation has the wider graph, because if there is a number here that's less than 1, whose absolute value is less than 1, so essentially if there's a fraction in front of x squared, it's going to be wide. And if there's a whole number, it's going to be narrow. So, our problem said to graph this, so let's go ahead and graph these. So what I will do is bring up my table by pressing second graph. All right, so there's our table. So let's just graph some of these. I'll do this one in red, and I'll do the other one in blue. So 4x squared will go, okay, so there's 0, our vertex, over 1, 2, 9, 10, 11, 12. Okay, and so 16 is all the way up here somewhere. So here is our parabola taking off towards the sky. Oops, gee whiz. Okay. And so there's 4x squared, and now let's take a look at what 1/3 x squared looks like. So x is 0, so the vertex is 0 also. At -1, it's 1/3 of the way up. At -2, it's 1 1/3 of the way up. At -3, it's 3 up. And I'm just reading the table here. See, I'm just plotting these points. These are the blue points here, right here. See, y2, this y2 is this y right here. And this y1 is this y right here. And the x's, of course, are the same because it's the independent variable. And here is our plot of y equals 1/3 x squared. Oops, gosh. Alright, and there we have it. Draw some arrows there. Perfect! Beautiful! Look at that artwork. That is truly artwork. Okay, let's move right along down to number 10. Write an equation that represents this graph. Oh, good, 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 good. Over 1 up 1, over 2 up 4. Okay, so we just affirmed that our equation is just going to be plain old x squared. It's concave up, so it's going to be a positive, and it's shifted up 1, 2, 3 units, so it's a positive shift of 3. Y-intercept of 3, so we shifted up 3 units. What is the vertex of the graph? Well, the vertex, let's use some of that vocab. The vertex is right here. It's either the minimum or the maximum. We always write it as an ordered pair. So the vertex is 0, 3. Is it a maximum or a minimum? Well, if we travel along the parabola, will we reach the bottom of it or the top of it? We'll reach the bottom of it. And if we reach the bottom of something, well, that's the minimum of something. So it's a minimum. What are the roots? Okay, remember, our roots are where a parabola intersects the x-axis, like that beautiful parabola I just drew. Does this parabola intersect the x-axis? No. So there are no roots. There are no real roots. So if you want to be fancy and impress me, you could write there are no real roots, because there are imaginary roots. But for our purposes, you can just write NA. Okay? Move along to 13. David tosses a water balloon from the roof of a building. Oh, this is great. This is great. Good for David. The table of data represents the height, in meters, of the water balloon at a given time. So this table, what's happening here is it's relating two variables, time and height. So when we graph these, it's very, very important to know which variable is being represented on which axis. Remember, time is always our independent variable. So time will always go on the bottom. And so height is a function of time. So here's our height. And it looks like at time 0, at time 0, the height was 42. And then as time goes by, the height comes down like this until the water balloon eventually hits its target. And notice that our graph does not go all the way to where the height hits the ground. So we don't know when it will hit the ground. Using your graphing calculator, find a regression equation for the data. Round it to the nearest